Hello everybody. Okay, hopefully you can hear me. Is it working? Maybe just make a little comment there, somebody, that it's working, but I think it's working. So I'll just keep an eye on the comments. Is it working, Lincoln says. I hope so. Can somebody say that they can see me or hear me? Oh. Really, it's not working? Or it is working? Okay, I don't think it's working here. Can you see me? Oh, it's working. All right, so people are saying it's working. Hey, Cooper, Warren, Will, Liam, Hannah. Oh my goodness, it's a long list. Well, hello everybody. Good, good, good. Nice to see you. Hope everybody's good. I'm standing out on my porch. Can you see the snow? Maybe you can, maybe you can't, but it's freezing. So today we're going to do a little review on how to find the area of trapezoids. And we're doing it in 3 ways. And they're all 3 ways we looked at before in our unit. The first one is decomposing the trapezoid into triangles and rectangles. The second one is doing the whole shape and making the trapezoid into a rectangle and then subtracting the triangles to get our answer. And then the third way is using the formula, which you already have in your notebooks, but we'll go over it again. And so no matter which way we use, we're going to end up with exactly the same answer. Okay? So I'm going to close the door behind me, and that's our smart board for the day, which is not very smart. Have a look at it. Okay. Not too bad, huh? So let's just check in. Everyone's saying it's working? All right, we're still working. Can you still see me? Can you just make a little comment? Otherwise I won't start just yet. Okay, is it working still? Just checking to make sure it's working. Very smart. Okay, it's working. All right, good, good, good. All right, so here we go. Here's some questions, so just a couple on the board. And so let's start off with the idea of decomposing. So here's the trapezoid, right? If you look at it, it's actually 2 triangles there and the rectangle in the middle. So that should be a little bit familiar, right? So let's do it this way. Let's take a look at these numbers here, because you can see from the trapezoid that we've got 2 different widths, one at the top, one at the bottom, and obviously the bottom one's much, much bigger. The thing to look at first is, in order to determine what the base of these triangles is, we have to look at the difference between the 2 widths. And you can see the difference between these 2 is 4. So we're assuming that these triangles are exactly the same. So what we need to do now is we need to say, okay, for the difference of 4 between this base and this base, that's going to be 2 of the 4, and that's going to be the other 2 of the 4. So obviously together those make the 4, which is the difference between them. Very important before we go too much further, we got to make a little addition, or not an addition, an alteration. We can't call that 12 anymore. And if we don't cross it off and get rid of it, or change it I should say, then we're going to get ourselves a little bit confused. So this is now also 8. Okay, because the 8, the 2, and the 2 make the 12 that we originally had. So far so good? Alright. So now, let's look at the triangles. So we're going to first, in our decomposing, take a look at the triangle's area. Alright? And we've got 2 of them the same, so we'll kind of just do a little shortcut in just a moment. Now, triangles from yesterday's lesson, remember you're doing base times height, but then you're dividing in 2, because really by doing base times height, you're actually thinking of this as a rectangle. And it's not. We only want half of it for the triangle. So base times height, we got 6. 2 times 3 is 6. Divided by 2 is going to give us 3. So what we can do on the left, without complicating life too much, is we can say that area is 3. Same thing over here. 2 times the height of 3 is 6. Divide by the 2, you get 3 again. So we've got through decomposing, we've got the area of 2 of these triangles. Now what we're going to do is find the area of the rectangle. So let's just back up for a second. We've got the area of 3 and 3, so a total of 6 units squared for the triangles. Now let's go ahead and put in the rectangle. Now there's no business of dividing by 2 on the rectangle, it's just simply base times height. In this case, remember we made an adjustment to that base so we didn't mess up here. Base of the rectangle is 8 times 3, which is 24 units squared. Let's hope we're still on the screen, I think so. Alright, so now let's put it all together. We've got the triangles over there, we've got the 6 units, and we're going to add in the 24 units. Now, to be technical, we've got to put the squared in there. And we end up with an area of 30 units squared. So 30 units squared is the area of the trapezoid. We just got it that way using the decomposing method. Okay, now, let's back it up now and see if we can do some more work on just creating a hole. Now, it's not like the smartboard where we can erase. I'm afraid we're stuck with what we see. But the whole concept is creating an imaginary rectangle around the whole trapezoid. So hopefully you can see this now. I don't know if you can, but that's the rectangle. So what we're looking at now is a total width of back to 12, because the 2 plus the 8 in those segments plus the 2 is 12. And we've got our height, which is 3. So the idea in the whole method here would be (36), which is the rectangle. But now we have to subtract these imaginary triangles that are on this side. Now it's really the same thing that we had before, because we know the area of these triangles are 3. So the corresponding triangle up here, which is the second half of this imaginary rectangle, where my finger is also going to be 3. So when you divide them by 2, you get back to your 3. That probably sounded a bit confusing. But let's just go with the idea that these are both 3. So the idea now would be subtract a total of 6 for the triangles, which came from that 3 plus that 3. Alright, so we're going to subtract those out because we have to get rid of these imaginary triangles because they're not part of our trapezoid. And sure enough, we get what we should get, which is 30 units squared. Okay, so that method right there was the whole method, subtracting away these imaginary triangles to try and get our answer. Now the final answer, well, the final example I should say, is using the formula. Alright, now in your notebooks you have the formula. Just checking on the comments. Anybody got any questions yet? Yeah, Hannah, you're right. If you missed the beginning of this, it somehow records itself and it'll be on my website, on the YouTube site, so you can go back and watch whatever you missed. And if it didn't make sense at any point, go back and re-watch it. Alright, so this final one, the formula. Now I'm going to adjust it down a little bit because I just want to make sure you can see what I'm doing at the bottom. Hopefully we're good there. Okay, so the formula that we have in our notebooks is just a little bit complicated. The formula takes into account that we've got 2 different widths. One at the top which is shorter, one at the bottom which is longer. So we have to take into account those, and what we do for our formula is we add the 2 bases together. So base 1 is at the top, base 2 is at the bottom. We add them together and we're basically finding an average of those 2 by dividing by 2. So in a very simple kind of way, this is like finding the mean average of the top width and the bottom width. So we can use that. Okay, and then what we're going to end up by doing is multiplying by the height. Now we said yesterday in the triangles work, you got to make sure you go with the perpendicular height for this, because just for the sake of argument, if we had a 4 as our diagonal height, we do not want to use that, because we only want to use the perpendicular height, meaning it's the 90-degree angle of two lines, where the base is and where the height is. Where those two meet, that is the one we want to use. So it's in fact, it's that number 5 we want to be using. Okay, so let's add them together. 3 plus 4 is 7. That's our base 1 plus base 2. We're going to divide by 2. And we're going to multiply that by the height, which is 5 over 1. All right. So we look to see if we can cross simplify. Unfortunately, we can't with these numbers. So we just got to go for the big numbers, which are not too big. 35 divided by 2. And when we do that properly, something's going wrong. Oh, I know what's going wrong. I should have done this on the first one. Sorry about that, everybody. Got the wrong number. Just realized I should have used the top numbers. Anyway, we'll go for this one at the bottom, because the concept is exactly the same. I just messed up the numbers. So in the end, this should be 17.5 units squared. So actually, that is the answer to that bottom one. Again, I messed up. So here's what we can do. For a little bit of practice, since you know the answer is 17.5 units squared for the bottom one, see if you can arrive at the answer of 17.5 on this second one using the decomposing way of combining the two triangles plus the rectangle, and then also use the whole method where you pretend that you've got a full rectangle and then subtract the value of that triangle and that triangle. It's good practice, even though you know what the answer is. It's just a good practice to confirm that you can in fact use those strategies to get 17.5. Okay, I'm going to appear awfully close back in the screen. So, thank you, Warren. Yes, everybody does make mistakes. That's the way it is. So I hope this made sense. What I've done around about now, 9:15 this morning, I've scheduled a practice to go out onto Google Classroom. So right now, everybody's got practice to be working on, if you want. So this method, these three methods, are just possible selections of how to find the area of a trapezoid. And as we always say in class, does it really matter which method you use? It doesn't. As long as you know the three and you can select one that seems to fit you best. And it's never a bad idea to use your favorite method to get your answer, and then double check your strategy double check your answer rather with another strategy. Okay? So, okay, tomorrow at 9 o'clock, instead of going YouTube Live, I'm going to try something new. I'm going to try Zoom. It's one of those sites that companies are putting, they're giving us like free access for up to 100 people, I think it is, which will take care of us because we're under 100 in all three classes. So we got it free through a month or so. So I'm going to give it a try tomorrow. So here's how that's going to work. I'm going to send you an email to your school email somewhere around about 8:45. I know you got to get up earlier. Sorry about that. But around 8:45, I'll send you an email to your school email with a link to how to get onto Zoom. It looks like you need the website and you need a code, which will all be in the email. And then log on. You can do this through audio only if you want, or if you have a webcam and and you're allowed to use it and want to use it, you can do that too. So you have a couple of options. Okay. I'm just checking out the comments. Oh, yes. Yesterday we had some technical issues getting YouTube Live going. But then I did actually do a video that I posted, I believe. So you should get to see that if you missed the lesson live. Sorry about that. I tried everything and my oldest son Ryan was helping me. But we had some technical issues which we've now resolved. No, Hannah, I can't see you. No. This is just one camera here. Okay, I'm just looking at your comments, not used to doing this, but okay. Nope, Malia, I cannot see you. All I can see is a little webcam on my computer. So I can't see anybody. Okay. Zoom, Owen, is like, I guess it's a bit like live FaceTime, but it's not the same platform at all. When I've gone for illustrative math training, a couple of you have known that I've gone a few mornings over the last year or so. They use Zoom. So it's like a webinar, which is a way you can have a meeting but not actually get face-to-face. You just do it through video and audio. That's what it is. No, Janelle, it's not Zern. Zern is another thing I think I put on Google Classroom for you. So that's nothing to do with this one, actually. Yes, Finley, you're right. Will, check your email. I sent you something that I would have done with you in Flex, something you asked for in the conference, but I obviously we don't have Flex. Okay, everybody, so let's kind of end here, and I'll be back again tomorrow morning about 8:45 with your email, and Zoom will go live on on Zoom at 9 o'clock. And that's a bit different because you can see a little screen of me, but you'll also see the main screen where I can use it like a smartboard from what I can see. And tomorrow what we're going to work on is, I can't remember. Oh yes, finding surface area of rectangular prisms. So I'll get working on that this morning so we're all set up for tomorrow. All right. Lincoln, are you going to send it to Google Classroom for Zoom? Oh yeah, actually that's a good idea. I think I can do that because I don't think you have to have your own personal school email for this. Anyway. All right, friendly, you're welcome, everybody. I hope it's helpful. I miss you guys. Sorry I can't see you, in person, but we'll get back together again. So, all right, that's it for now. Enjoy the day. Can you believe it snowed? Terrible. It's freezing out on my porch. Anyway, have a nice day, and if you want, go to Google Classroom. I forgot in Google Classroom. Not only is there a practice, there's another video I put up, which is like, well, it's actually on the area of trapezoids, but that one is using something called Vittel. It's an iPad app that I got some time ago. So check that out as well if you want. Can't see anything, it's just a whiteboard thing. Well, you can't see me, it's just a whiteboard one. Okay, everybody, enjoy the day, and I will see you tomorrow. I gotta get a good sign up, but I don't have one today. So goodbye for now, okay? Enjoy the day. Bye, everybody.